So let's study why we need data structures. Assume I have students data with me, roll number, name and marks of the students. Okay, so some maybe you have some encoding roll number, so I will just write some simple ones, something like this, and I have some names of the students and so on, and I have some marks here. Out of 100 maybe we can assume, right, some marks like this. Okay, so when a student's data is given to you, I have one criteria. Actually I want to give gold, some award to the first highest scorer. Okay, I want to give some medal, I want to give maybe some gold medal kind of thing, who has secured the highest marks in the course, right? So when this data I have with me in this format with roll number, name and marks of the students, right, my criteria is to give award. To whom should I give the award? I want to give gold medal, or I want to give top 1, 2, 3 awards. Okay, 1, 2 and 3 awards I want to give. First person, second and third highest scores, I want to appreciate them. Now what I have to do in that case, how do I find that from this given data what we have with us? How do I find out who got highest marks, right? So generally what we will try to do, we will try to sort this data with respect to marks. We will try to do sorting. What is sorting? Again, arranging numbers in increasing or decreasing order. So I will try to sort this data, whatever data I have with me, with respect to marks. I am trying to do sorting. After sorting, it is very easy for me. The first record in the data set, the first record will be the first prize winner. Then the second record will be the second prize winner. If I do in descending order sorting, then the third prize will be the third record will be the third prize winner. Then it is very easy for me to find out who is the first topper, second and third topper. For that, what I am doing, I am putting some additional effort. In sorting the data. Okay, I am trying to sort this data with respect to marks, because my criteria is to give the award based on the marks. Okay, this step is clear. I have another criteria C2. What is that? I want to find out names of the students. Okay, I want to find out the number of students along with their I mean to say, see, number of students starting name with A, number of students whose name begin with B, whose name begin with C, whose name begin with D. This I want to find out. Okay, so the question here is that find out most of the students starting alphabet is which letter? Is it S? Generally we see S has S, R, and we have many people with these alphabets. So I want to find out in this name column, I want to find out among the students data whatever I have with me, for each alphabet how many students are there with that their name beginning with that alphabet. Okay, how many students first character is with A, their name starting alphabet is A, or how many students are having their starting alphabet as B. Okay, or how many students are having their starting alphabet as C. This we have to find out. So again, in that case, what I have to do, I have to again sort this data. I have to do sorting of this name field. Okay, I have to do sorting of this name field. So for the satisfying this criteria, you have to sort this data. Again, why do you think? Maybe you may have answered criteria 1. See, giving award. If the student list was just maybe 100 students in a class or 65 students in a class, by maybe manually seeing you can find out who is the highest scorer. But what if I have 10,000 students list with me? In that I have to find out who is the highest scorer. It is time consuming for me. That's why I am going for sorting. Again, that sorting will take time, right? It requires lot of computation, because sorting 10k records is little, the complexity, the time and space will be little high, because I am having huge number of data with me. Sorting is difficult. Even for the criteria 2, to find out students whose name begins with R, how many students names begin with R, S, A, B, I want to find out. For that also I have to sort it. For that also I have to sort it, right. So you see, you see this first criteria, to find out who is the highest scorer in the 10,000 student list, I am putting some extra effort of sorting that data. What would have been the easiest way? The easiest way will be, what if whenever I am storing the data, with me in my Excel sheet or some database or somewhere, wherever I am storing it, right, what if I store them in sorted order? Then extraction is very easy, right? Okay, so criteria 1, you see, you understood the criteria 1, that is to give award to the highest scorer. Okay, so in that I have to sort the whole 10,000 lines of data. What if the data is inserted into the file in sorted order? Then retrieval is very easy, right? Retrieving is very easy, because see, I am having Excel sheet with me with roll number, with name and marks. When I am entering first student detail, let me enter as it is, something like this, or some 82. When I am entering second student detail, the second student detail is 2, some CDE and 93%. Then in that case, you rearrange the order. You put it like this. You put 2 first, then CDE, then 93, then you put 1 like this. Then the third record is coming, again you do sorting and store it. Let that take time. Inserting data into this file, let it take time. But retrieving should be very fast. Why? You see, today you use so many applications. We want everything to come very quick. When you click a button, you are booking something, making some payment, or browsing something. When you click something, it has to immediately play. Right? It should not take so much of time retrieving the data. It should come very quickly. We all want to retrieve the data very fast. But let it take more effort while storing the data. Okay, right? So that is the point here. I want to say that unnecessarily you are putting extra effort of sorting. This is one computation step, that is sorting. You are doing some kind of computation on the data to satisfy your query. That is, who is the topper of the among those 10,000 students we have in our campus who got highest marks. To find out that, I have to do some extra computation which is taking time, and we don't want to spend time retrieving the data. We want everything readily available. You all know, when you browse internet, you want everything to work very fast. You are playing some YouTube video, it has to come immediately. Once you click it, it should start playing. If it is buffering, means you feel irritated there. You don't like to watch that, no? You face some problem there, right? So that's the reason we want retrieval to be very, very fast. For that, what I have to do? I have to store it. I have to store the data in a particular format. In which format should I store? The format which you need to access. In whichever format you want to access that data, in that format you have to store the data. Let that storing of data may take time. Let it take more time. But retrieval, whenever I want to access the data, I want it to be very, very quick. Because we all are, retrieving should be very fast. We all need retrieval to be very quick. So data structures is all about, from here only we can frame the formal or informal definition, whatever you say. Data structures is all about storing and organizing the data such that the retrieval is faster. Okay, data structures helps us in effective storage and organizing of data such that the retrieval is faster. Okay, so storing, organizing data, storing and organizing data such that the retrieval is faster. Okay, so that is the basic definition of data structures. Right? So we have different types of data structures. Okay, so depending on the problem, you can choose that particular data structure. Depending on the problem, you can choose that particular data structures. Right? So this is just to explain you why, a simple example to explain you why we need data structures concept. Why we have to study this or why you have to use this. It helps us in neatly organizing the data and storing the data such that the retrieval is faster. We have different kinds of applications. We have different kinds of data structures are there. We use maybe I will just something, linked list is one, stacks is another one, queue is the other one, trees, graphs, like this we have some certain data structures. Every data structure has a specific pattern. They follow some pattern of storing the data and organizing it and retrieving the data. Again, array is also one data structure, right? So they have their own styles. Depending on the problem, depending on the your criteria, you decide which data structure to use. So when a scenario is given to you, once a scenario is given to you, based on the scenario you decide, okay, if it says that you have to store data will come anytime, data will be there is no, I cannot say how much data will come, I cannot say how much data will come, right? You are running a camp, you are running some medical camp in some village, I do not know how many people will come. It is free medical camp, but I cannot guess, will 50 people come or 100 people come, I do not know, right? In that case, what is that problem here? Storing of the data of those patients. What should be my size of array? Should I declare A of 100 or should I declare A of 1000? It's a problem. That's why we use linked list, where we can dynamically increase or decrease the size of the array or the number of patients. So depending on the context and the problem, you can choose your data structure. So ultimately it is that data structures helps us in effective storage and retrieving of the data. Okay, storage, organizing and retrieval, but the important condition is that retrieval should be faster. Okay, so these are different things, we will learn them one by one in this course.